Alright, welcome back guys. In this video here, we're going to discuss briefly regards correlation, especially linear correlation through scatter plots and maybe a little bit of regression analysis, not so much about it. Let's start out with a definition. So if you have two variables, let's say just x and y in general. So when we observe the values of one variable are somehow associated with the values of the other variable, and when we mean by associate, we mean like if one value is increasing, the other values are also increasing or decreasing. So they're correlated somehow. So we say that there is a correlation, right? So a correlation exists when two variables, one variable increase, the other one decrease or increase at the same time. And a linear correlation is when the correlation itself, the pattern itself is being can be observed through a line. And we say that the correlation is linear because it can be described through a straight line. And the coefficient R measures the strength of the linear relationship between the two variables x and y. So I'm not really presenting any formulas, complicated formulas how to do this. I'm just going to briefly just touch on the surface of it, kind of give you a big picture of what's going on here. So what do we mean by two variables being correlated? So let's say in this case here we have a person's height, which call x, and then the belly button height, the same person, called y. So what we can say is as the values of x increases, we also going to notice that the values of y increases. So that establishes a correlation, right? Or another example would be, as I spend more time studying, or the number of hours spent a student spend time studying, positively correlated to the letter grades that the student get in the class. Normally, and that's the case there. So we'll come back to this example here, but I can touch more on the correlation part. Let's say if we have a scatter plot, x and y, okay, and we have these data points here. Let's say we have that. Here's just a set of points being plotted on this x and y coordinate system. So in this case, we can say x and y are related positively. So in this case, we can say that positive correlation. So positive correlation, right? So you see how as x increases, y also increases as well. So the R value, the R value is what we use to measure the strength, how closely x and y are related. Notice how these points are not on the straight line, they kind of scatter a little bit. So that it's not 100% correlation, but it's somewhat close to that. And we can say this is roughly about 0.85 something, roughly around there. So when R value equal 1, that means perfect correlation. That means all the points are on the straight line. So say when R is 1 is when we have all the points like this here, on a straight line. That's R equal to 1, right? That's R equal to 1. So R value measures how strong, how close these points are next to each other. In other words, R measures the strength of the linear correlation. So let's give another example of a negative correlation. So a negative correlation. So let's say x and y. Negative correlation. Let's see. We have as x increases, y decrease, right? Something like this. So this would be a negative correlation. Right. So negative correlation. Negative correlations. So I'm gonna guess R is roughly around a 0.7 in this case. In this same video, I'm gonna show you guys by using technology we can actually find the R value. We don't have to do the algebra, by hand, given a data set, we can actually compute the R value, and you can look up the formula. Certainly, it's not a fun one. Let's see if I can find a formula for us here in this case. Where is my formula sheet? Stats, formulas. Oh, there it is. Correlation coefficient. There it is. So certainly, we're not gonna spend time in this class doing this by hand here. Okay. We are gonna use technology. Okay, going back to my notes. So we got positive and negative correlation. Another one is perhaps no correlation at all, is something like this here. This would be an example of no correlation. When the points are kind of scattered and there's no apparent pattern. So I'm going to say something like this here. Kind of like no patterns at all. So in this case, you know, R value is... So I'm going to say no correlation, and perhaps, you know, R value is, you know, closer to 0. So let's say maybe 0.3, something like that, right? So these are example of positive correlations and negative correlations. One thing we want to make a note is that just because two variables are correlated, just because two variables are correlated, you know, correlation does not imply causation. So that's one thing that we want to make a note of, okay? Just because two things are positive correlate or negative correlate, that doesn't mean one thing caused the other one to behave in a certain way. Okay. An example would be there is a correlation between beer consumption per capita and teacher salaries, but, you know, it's not because the teacher using the salary to buy beer which caused the beer consumption to increase, so that's not the case there. So that's just give you a funny example. Anyway, so let's talk about a scatter plot from this data set. So let's talk about this example here. In this example, we have 10 persons height and 10 persons belly button height. These are the same two heights from... These are the values from the same person. It's actually from last semester. We actually did this activity in class where I had 10 students volunteer to come up in the front of the room, and I actually take measurement of each student, their heights and their belly button heights as well, and record the data. So what we're gonna do is we're gonna plot this data through a scatter plot. And then we're going to discuss what does it mean to use regression analysis, what does it mean to find the best fit line and to predict certain values, okay? So I've already done the work because I don't want to spend 10 minutes doing this by hand. So I got the scatter plot already pre-sketched out here. You can do this by hand if you want to. It's pretty simple. You just do X and Y and scale the points and plot the points, okay? So we have this. I'm gonna say this would be our X, and this is our Y. So X means height, a person's height, and then this would be belly button's height. Right. So these are the 10 data points here. So what if, here's the question: what if I have a person say, okay, I'm 73 inches. Can I use this data set here to guess where my belly button height is? The answer is yes. It depends how strongly X and Y in this case are related, okay? So in statistics, we said we can figure out the best fit line. We can actually analyze this 10 data points here and figure out a mathematical model that is best fit the data. So something like this here, right? And we can figure out what is the equation based on this 10 points here. And the math behind that is a little bit complicated, but the idea is pretty simple, right? We find out, the best fit line. So we're going to say this is the best fit line. Okay. Let's say this best fit line, call that, y hat equal to, ax plus b, something like that. Okay, so that's just the slope intercept form for any line there. So that best fit line, we can call this, another fancy word is regression line. Okay, so let's say we do the math and get the equation of this line here. And then from there, we can say, I can use this mathematical model to predict a person belly button height, provided that the person's height is given. Right, so that's what we're gonna do here, and you are gonna do this at the end of the video. I'm gonna let you, do that on your own. This is actual live data, so you can trust this a little bit. So now I'm gonna show you guys how to obtain this best fit line, this regression line here using technology, using a TI-84 graphing calculator. So I'm gonna go to my app here. All right, so home. Okay, so what you want to do is you want to go to stats button, and then you're gonna go to edit. Okay, and then I'm gonna clear this out, clear. Okay, and then you're gonna enter under L1, you are gonna enter the height of the 10 students. Okay, so I have 71, enter 74, enter 72, enter 71, enter 72, enter 66, 69, 73, 60, 70, and then for the L2 columns, let's enter the students' belly button's height, 42, 48, 44, 43.5, 43.5, 42, 42, 44, 35.5, 41.5. Okay, so we got all 10 data points enter. Okay, and now we're gonna tell the calculator, hey, I want to do a regression analysis, linear regression analysis on this data set, and then the calculator is gonna give us the best fit mathematical model line or equation line that we can use for this data set. So we're gonna do stats again, and we're gonna go over to calc, and you want to go to option 5, linear regression ax plus b, press on that, and you're going to do second L1 comma second L2, because we have to tell the calculator that the data set we want to apply the regression analysis on is the column L1 L2 data set. Press enter. Okay, so we get all this here. We get what the coefficients are. We got A and B, those are the slope and the y-intercept for this line here. The R value, which is the correlation coefficient R, which measures the strength, how close are these points, and it's about 0.9. 0.9 means these points are pretty close to each other. If your calculator doesn't show you the R value, what you want to do is you want to do second cal log down at 0 here, and then that will be under D, diagnostic on. You want to click that and then turn that on. Okay, so that would be second cal log, which is down the bottom by the number 0 there. Anyway, so we got here's a coefficient. Let's see here. I got A is 0.69, so equation. So I'm gonna write the equation. Y hat is 0.69 x, and then B is negative 5.6, negative 5.6. All right, so this is our regression equation. All right. So what this means, and then the R value is pretty close, so that means 0.9. That mean these points here are pretty close to each other. Okay. So now with this equation here, okay, what I would want you to do is, let's see. So the fact that we have the R value 0.9, that means this model is pretty good at predicting. So this is what you can try on your own here. So try this on your own. You can pause the video if you want to. So try this. Okay. First for the X, measure your height. Okay. I want you to measure your height, which is the X value, and then plug X into y hat equal to 0.69, x minus 5.6, and let's see if you actually get a pretty close value. Okay, so once you measure your height, plug the value of your height into this equation here, this regression equation, get the answer. Then after that, you want to compare that answer. So you say compare the answer, the predicted answer, to your actual height. Remember, you have to measure in inches. Okay, when you measure your height, compare the predicted answer to, not the actual height, but your actual belly button height. Actual belly button height. You can measure to verify and then verify it. Okay, see how good this model is. Okay, so that's pretty much it. You know, given a data set, we plug into the calculator, tell the calculator to perform regression analysis on it, and then we get a model. Use that model to predict things outside the data set, and you know, depends how strong the relationship is, how close are these points to each other. We might get a good prediction. We might get a bad prediction. Okay. The method that we use to obtain the best fit line, or the regression line, this is called the smallest possible sum of errors. So just quickly, the math behind it is you do a bunch of calculation between the observed value and the actual value. So you do y minus y hat. So this is the residual. Okay, you do a bunch of this here, and you square it up, and you do a bunch of calculation, and you figure out which of the line has the smallest possible sum of square errors. And if you're really interested in how the math behind this here, you can certainly find a bunch of YouTube videos on it and explain how to do it. In this class, we try to minimize the algebra that we are spent doing. Here's an example you can work on your own here. And there's a couple, there's a bunch of problems in the homework as well. Okay, so feel free to ask questions on this in Zoom if you have questions about this note, and I will see you guys in chapter 3.